This is section 5.1, operations with polynomials. So you have evaluated powers before, and now what you're going to do is multiply, divide, and simplify monomials and expressions involving powers. And you're going to add, subtract, and multiply polynomials. So your new vocabulary is simplify, which really isn't very new. I always ask you to simplify your answers, and degree of a polynomial, which may be new. So the concept of the properties of exponents, you can pause this if you want to study this chart. You did have it in Algebra 1, so these are just all of our properties of exponents, and we're going to be using these in this lesson. A monomial is expression in simplified form when there are no powers of powers, each base appears exactly once, all fractions are in simplest form, and there are no negative exponents. So when it says there are no powers of powers, you can't have x squared to the fourth and call that simplified form. And you also, when it says each base appears only once, you can't have x squared times x to the fifth. You have to combine those exponents. All fractions are in simplest form, and there are no negative exponents. You're never going to have a negative exponent in your final answer if it's in simplified form. So simplify the expression, a to the negative third times a squared b to the fourth times c to the negative 1. Now we're going to use our associative property of multiplication, and we're actually going to put our a's together. So we have a to the negative third times a squared times b to the fourth times c to the negative 1 power. When we combine our a's, when we're multiplying these, we actually add our exponents. So we end up with a to the negative first power, b to the fourth, c to the negative first. Now those negative exponents cause those variables to be moved to the denominator. So b to the fourth can stay in the numerator, but a to the first and c to the first are going to go to the denominator. And it's understood that 1 is the exponent, so we can just write it that way. It's fine if you write a to the first, c to the first, but it's not necessary, and it looks better to write b to the fourth over ac. So determine whether c to the fourth negative 4 squared of c plus 18 is a polynomial, and if it is a polynomial, state the degree of the polynomial. So in order for it to be a polynomial, it means that it has to be a series of monomials that the exponents all have integers or whole numbers as exponents. And so if I rewrote this, it would be c to the fourth minus 4. When you have the square root of c, that's c to the 1/2 plus 18. So this is not a polynomial because of this exponent here that's 1/2. So part B, determine whether negative 16p to the fifth plus 3/4 p squared q to the seventh is a polynomial. And this is a polynomial. We don't have any negative exponents. We don't have any variables that are in the denominator, and all of our exponents are whole numbers. So that is a polynomial. The degree of the polynomial is always the sum of the degree of the highest degree monomial. Now the way you find the degree of a monomial is, let's look at this monomial here, because that's one of the terms of our polynomial. You look at the exponent on the variable or variables that are in that monomial. So this has only one variable, and its exponent is 5. So this monomial has a degree of 5. Now this one over here has 2 variables. So what you need to do is you actually add the exponents of the variables, and so this monomial has a degree of 9. Now the degree of a polynomial is the degree of its highest degree monomial. So this polynomial has a degree of 9. And a common mistake people make is they say, oh, I'm going to add 9 plus 5 and say this has a degree of 14. That's not how you do it. It's the highest degree monomial. So this one, determine whether x squared minus 3x to the negative first power plus 7 is a polynomial. If it is, state the degree of the polynomial. This is not a polynomial because it has a negative exponent. So simplifying expressions, polynomial expressions, you need to combine like terms. In order for something to be a like term, the variable portion of it has to be exactly the same. In other words, the variable has to be raised to the exact same exponent. So first let's simplify this. So we have 2a cubed plus 5a minus 7. We need to distribute this negative sign to every term here. So we have minus a cubed plus 3a minus 2. So combining our like terms, we have an a cubed and an a cubed. So that's going to give us 2a cubed minus a cubed is just a cubed. And then we have an a and an a. So we have 5a plus 3a, which is 8a. And then we have minus 7, that's our constant, and minus 2. So negative 7 minus 2 is minus 9. And that's our simplified polynomial. So simplify these two polynomials, and it says align like terms. Now another way that you can do this, if you don't like the way this one was done here, is you just line up your like terms. So I'm going to write 4x squared minus 9x plus 3. And underneath that, I'm going to write the other polynomial lining up the like terms. Oops. And now I'm just adding these. So 4x squared plus negative 2x squared gives us positive 2x squared. Negative 9x minus 5x is minus 14x, and 3 minus 6 is minus 3. So that is our final answer. Simplify by using the distributive property. So when I distribute negative y, we get negative y times 4y squared minus y times 2y, and then minus y times negative 3. So when I simplify this, I get 4y cubed, and that's a negative, minus 2y squared. Now we have negative y times negative 3, so this ends up being plus 3y. E-scales. A small... Can't find my microphone. So a small online retailer estimates that the cost in dollars associated with selling X units of a particular product is given by the expression 1,000 times x squared, that should be x squared, plus 5x plus 500. So the cost is this, and then the revenue from selling the products is the polynomial 10x. Now write a polynomial to represent the profits generated by the product if profit equals revenue minus cost. Well, the revenue is this 10x, and the cost is this polynomial here. So the profits is going to be 10x minus, and you need to put this in parentheses, 1,000th x squared plus 5x plus 500. Now when we simplify it, the profit is 10x minus 1,000 x squared minus 5x minus 500. And combine like terms, we get the profit of x. And you always want your lead coefficient first. In other words, the highest degree polynomial comes first. So we're going to have negative 1,000th x squared plus 5x minus 500. Oh, I didn't distribute. So multiplying polynomials, this is a lot like FOILing, except now we have more than one term here. So when we're multiplying polynomials, we need to distribute this a squared to every single term over here. We need to distribute 3a to every single term over here. And we need to distribute negative 4 to every single term over here. So what this is going to look like is a squared times a plus 2 plus 3a times a plus 2 minus 4 times a plus 2. And so now we can multiply it through, so we get a cubed plus 2a squared plus 3a squared plus 6a minus 4a minus 8. And now, combining our like terms, we don't have another cube term. We have 2a squared plus 3a squared. We have 6a minus 4a minus 8. And that would be our final answer. And that's it for this lesson.